So, once again, thank you, Gordon Spleet, for taking the time to join us today to continue our discussion on troubleshooting leak test equipment. Last week, we focused on some of the design principles and design ideas that are best to keep in mind when you are creating, developing, building a leak test machine. Today, we're going to talk specifically about when your leak test machine is not working, is not functioning, is causing issues. We're going to talk about what you can do specifically from a maintenance perspective and some of the troubleshooting strategies that we have acquired over the years and would recommend to customers. So this presentation was created essentially from my experience to say, here's what I've done whenever a customer has called me in and says, "Hey, Russ, your piece of equipment isn't working properly. Fix it." So it's essentially that. And so Gordon has had a tremendous amount of experience working with leak testers as well. So wanted him to join up and then offer his experience in troubleshooting leak test equipment a little bit further than we went yesterday. So Gordon, thanks again for joining. And for those of you that are unfamiliar with Gordon Spleet, Gordon works for Cincinnati Test Systems and has been a part of the Cincinnati Test Systems team for
25 years.
25 years of leak test wisdom to share with us here today. So, like I mentioned before, Gordon and I started working together when I was an engineer at Cummins Engine Company in Columbus, Indiana. And so we got to work there. So we've had a long history of working together, one from customer supplier relationship to working together as teammates to help proliferate leak test equipment, specifically Cincinnati Test Systems leak test equipment. So thanks again for joining.
Sure thing. Thanks, Russ.
All right, so I just want to remind everyone what we do. So CapEx Sales, we represent ATC Automation, which is a sister company there to Cincinnati Test Systems. Always want to mention 85% of their business is with repeat customers. Cincinnati Test Systems, the largest leak test company in the world, which is hard to believe. Gordon Spleet, when you started with CTS 25 years ago.
Employee number 66.
Wow, just getting started. How many employees do we have now?
Oh, well, CTS over 200. CTS and our sister companies, our partner companies, we probably have close to 500.
Wow.
And then TASI overall, 1,500 plus.
Man, that is unbelievable. Unbelievable. Yeah. And we've kind of seen it all develop, and obviously just done our parts as it relates to helping on the leak test side and automation side for us at CapEx, but just incredible. So Duquesne Plastic Joining Solutions, so they are a global leader in plastic joining equipment, hot plate welding, vibration welding, ultrasonic welding, laser welding, any welding, joining of plastic material. That is what they do. And oftentimes, this is something that Fred McCoy used to say. Fred McCoy was the founder of Cincinnati Test Systems. He said, just follow around the ultrasonic welding companies, and then you'll find leak test applications, because every time they weld something, they need to leak test it. So I don't know if you remember him saying that, Gordon, but that's what he
Oh,
was.
yeah. Fred had all kinds of great ideas.
Yeah. And then Symetric is a part of Cincinnati Test Systems, but I mentioned them because they have a unique role at Cincinnati Test Systems, where they focus on high speed and process test and data management. So, and then Keller Technologies right here in Fort Mill, South Carolina, with a comprehensive line of industrial air filtrations, that's wet as well as dry filtration equipment. So that's what we do. So we're going to talk through again the troubleshooting issues that we see. So that we see in leak testing specifically. And Gordon, just chime in here. I know this is a presentation that'll be new to you, so we just want to leverage your experience in adding detail to what it is that I might mention here. So, of course, the analysis of a troubleshooting of an issue is key. Being able to step through and identify where the issue is actually coming from. So that's what we're going to talk about. So that's what we will go into here in this presentation. We're going to talk about seal leaks. We'll talk about air pressure settings and what we need to be considering there. We'll talk about tooling and clamping issues. Again, we dealt with some of that last week when we talked about troubleshooting, but specifically around the design and development of a leak test solution. And we're going to talk about instrument configuration now. This will be specific to Cincinnati Test Systems equipment, but can also be parlayed into or referenced for other equipment that you might have. And then we're going to talk about calibration and how having a faulty calibration can cause lots of challenges, which we have experienced more times than we prefer to count. Anything that I'm missing from this list here, Gordon?
No, I think that covers a lot of it, and there's subsections of all of it. So
yeah, exactly.
We'll dive into it all.
We'll delve into. So most of the time it is not the instrument, and we always I always start with that because the call that I get most frequently is, and I'm sure you've gotten it, Gordon, is, "Hey Russ, your junky instrument isn't working properly," and inevitably I go in. Of course, that's what we want to do. We want to make sure we provide the support. We go in. We have the beautiful thing about Cincinnati Test Systems instruments is it has a self-test cap in the bottom. And the very first thing that I do when I'm troubleshooting an application is I put that self-test cap in the bottom, and then I perform a self-test. It's a button right on the instrument. You just run a self-test, and it will do an analysis on the manifold inside the instrument to determine if there is a fault. And 95+% of the time, probably closer to 99% of the time, I get the green light and it says the instrument is good, the self-test passed. And of course, upon identifying that, then we start into this analysis process, identifying where's the issue. Is it seals? Is it pressure? Tooling, clamping, instrument configuration, things such as that.
Yeah, and recently in our newest instruments, the self-test is specific to the pressures of that instrument. So that wasn't originally in our older instruments. So now we've even upgraded the self-test capabilities of our devices so that it's more specific to your project.
Oh, excellent. That's a great point. So this is, analysis. It's kind of troubleshooting 101. So realize going in that it is likely a leak causing the issue. Now, it could be a leaky part. It could be a broken test line that is causing the problem. It could be, as I discussed last week, a drill that drilled a hole in the bottom of your fixture unknowingly, causing it to leak. So there are any number of things that are the problems. But with leak test equipment, the overwhelming majority of the time, the problem is that we have an air loss somewhere in the system, in the circuit.
Yep, and just for everyone, everything leaks, and leaks are not repeatable. So
yes, that's right. And when we do our leak test training, and we talk about that tortuous path, right? It's not a smooth path. That tortuous path it's one of the main reasons why it's not repeatable. So we talked about starting with the self-test cap, plugging that onto the bottom of the instrument. And if the self-test passes, then we move on to the next step. So we want to place our known good parts. So when you have a test application, it is important that you have a master part that you can use as a point of reference, as a sanity check, I like to say, that you put on the instrumentation and you press the start button. You maybe just run a test. This is what I would do if I was coming in to troubleshoot a piece of equipment. I'd take that known good part, I'd put it on the fixture. I would then run a test just to try to understand and wrap my mind around what's happening with this particular application, to see if I can glean any evidence that will direct me to a potential issue. So if If that doesn't work, then, or if I don't, so I'm going to get whatever I get out of that test, and then I'm going to press start. And then for our instruments, you can press hold, and the hold button is your friend. That's what I always tell people. The hold button is your friend, because when you can hold and maintain pressure in the part, then you can use Snoop, or in some cases soapy water, to spray onto the part, spray onto fittings, spray onto different components to identify where your leak is likely coming from. Because again, normally the problem is a leak in the circuit. So anything to add to that, Gordon?
Yeah, the hold button is the start button. So it's even got a triangle on it that looks like a play button. So
Yes, that's a good point.
This
presentation was probably written when we had I-21s, Forgive me. For sure. All right. So continuing to discuss here the identifying the issues. So we want to verify the pressure settings of the instrumentation, as well as the pressure source. So what I mean by that is if your test pressure is 80 psi, your regulator setting on your instrument will need to obviously be set to 80 psi. Now, we recommend that you put the self-test cap on the bottom of the instrument before you try to adjust the test pressure. And again, when you adjust the test pressure, the easiest way, in some cases, to do it is just to press start and then press hold, and then you can adjust the regulator up and down. Now, that's assuming that your instrument min-max settings are in a window that allows you to make those adjustments. Because if your instrument settings are incongruent with your target air pressure settings, then you will be frustrated because you press the start button and it's going to say overpressure. If you are overpressure, and then you will never reach minimum pressure if the target pressure settings are lower. But we also have in our instruments nowadays, there is a pressure setting feature where you can just go in, you can select adjust pressure, and then just adjust the regulator accordingly. I can't remember what menu that's under, Gordon. I normally just press the button until I find it.
I want to say global configuration.
Okay. So
testing my memory now.
Yeah, so global configuration, then you can find that pressure setting. So, but it's important that my point from a troubleshooting perspective is oftentimes it is the pressure settings that are the issue. So it's important to just keep that in mind. We're going to talk a little bit more about how to set those in a minute. You want to isolate the test circuit at every possible connection, and then use soapy water to identify, soapy water or Snoop, to determine if you can find a leak that way. So when I say every possible connection, you've got a hose or a line, an air line that's coming out of the instrument going to your fixture. Well, I would separate that, where that line goes to your fixture, and just plug that off. Find a way to cap that and just test that. So just run a test to see, is there significant pressure loss out of that section of hose? If there is, then obviously that could be the issue. I've seen these problems before in these hoses, especially with the NiloFlow, because it's so rigid that it has had, they'll have a small crack in it, but because of how it might be resting, it doesn't show up as a leak until you bump it or touch it, and then it begins to leak. Those are real challenges to find, but we've definitely seen that. Anything to add?
And then fittings, if you have force on compression fittings that are at an angle, that's another place to double check leaks.
Yes, absolutely. Those get bent. Oftentimes if customers are using like a CTS Connect, where you've got a line that comes directly out of the instrument, the operators can tend to abuse those. And they're just trying to get production and run parts, and then that creates where the connections are into the CTS Connect or into the instrument. Those can easily get bent, creased, and then crack as a result of that. Multi-station applications. We talked a little bit about this last week. Is just take the test lines out of the instruments and swap them. And then that allows you to identify, does the instrument or does the issue stay with the instrument, or does the issue stay with the fixturing? So that's, just if you have again, a multi-station application, or if you have multiple applications that may be manual, you can still, make that change to identify if where the issue resides. Is it in the instrument, or is it in the actual fixturing and tooling? All right, let's talk about seal leaks. The most common problems that I experience, and I'm sure Gordon, you can attest to this. The most common problem are seal leaks because the polyurethane seals that we would recommend that we use, or the O-rings that are being used, they wear out, they cut, they get debris on them and cause leaks. And this happens. We talked a little bit last week about how important it is to have the compression stops. What are the technical terms?
A positive stop. It's either in your tooling or on your rod cylinders.
Yes, thank you. So a positive stop, so that the cylinders don't continue to press your part into the seal. So if you have a positive stop, of course, it's going to continue to maintain force. That cylinder will continue to maintain force down onto the part, but it will not essentially use your part as a die to cut your polyurethane seals. That's a common problem that I see with customers that might make their own tooling, or they might have a company build a leak tester that's never built a leak tester before, and they effectively turn their system into a die cutter for their seals until they get that pressure adjusted. Anything to add there?
No, making sure your seals are aligned, straight alignment rather than at an angle, because that'll cause wear points and also a weak joint in the seal.
Absolutely, yeah. So that's a great point. Something else to consider there is the durometer of the seal, right? So that can cause premature wear, or in the case we have, CTS has long been trying to figure out the best material or media to use to make up our seals. And now all of our seals are fiber reinforced to help with their durability. Is that a correct statement?
Certain ones. Yeah,
okay.
So urethane, and then different durometers, and then also adding fiber fill to give rigidity to them so that they have durability long term.
Absolutely, that'll help prevent the cutting.
Yeah.
So incorrect durometer, common problem, right? Too hard or too soft. A soft durometer, again, is that could likely lead to premature wear, which is going to cause leaks. Or if it is too hard, then it's not going to, especially on complex sealing surfaces, it's not going to comply, and therefore it might work on one part, but every part is a snowflake at some level, so it's going to maybe not work on the next part, right?
Yeah. It also depends on machine surfaces or as cast surface as well.
Yes, that has a huge difference. That's a big deal. That is a big deal. So incorrect profile or alignment. So the alignment doesn't match the part. This is what Gordon mentioned as sometimes as a challenge, right? We design and develop tooling, and then we create the tooling, and then we get the actual parts that we're going to use on the tooling. And because of how they're set into the tombstones whenever they're machined, they come out and they're not exactly as we had expected from the drawings. So the alignment doesn't match up. So you've got a part, and you put it on your fixture, and it has the dowel pins, but the seals don't line up, and therefore we have maybe some small gaps or some intermittent gaps that can cause some problems. And I'm sure you've seen that, Gordon.
Oh yeah. So in machinery build, you always need to build in some capability for adjustment because of that reason.
Yeah, for sure. And what we see most often is when a customer goes from pre-production parts that are prototype parts essentially, and then they actually get the production parts, which are from completely different suppliers, and so we really do need that ability to make adjustments for the fixturing in order to accommodate those parts.
Oh yeah.
Too much clamp force. Again, that's a problem. I know I have some customers that use hydraulic clamps to do the clamping. And in some case, when you've got a large surface area, you need hydraulics to overcome the force of the air pressure that's going to be pushing back. But if you don't have positive stops and you're using hydraulic clamps, you're just going to
Yeah.
turn it into.
That reminds me of a runoff years ago where I watched us test the first part, and a slide sheared itself because of some hydraulic clamping force that got tweaked prior to runoff. So
Wow.
yeah,
That was unexpected. I'm sure not fun to deal with.
nope.
I had a test one time. Speaking of runoffs and seals, we had an application. A customer came in and this was early days, long time ago, and we went to do a runoff, and the runoff was just perfect. I mean, it was amazing how good the parts ran. I think we went to lunch and then we came back and the guy that was project manager, he was like, I have some bad news. And we said, well, what is it? What is it? And he said, well, we had switched out some seals prior to the runoff, and one of the cylinders where the air pressure was going to be put into the part, they had replaced that with a seal that didn't have a hole in it. So we were testing the back of the seal essentially, and the gauge R&R was, I mean, it was like 2%. It was amazing. So then of course we had to do all that work over again.
Oh yeah.
That happens. So sometimes with our CTS connects, or if you have fast test connectors as well, those develop what are called internal, or what you see as internal leaks. And even though we try to design these connectors so that they don't leak in a way that's going to actually pressurize the part, it can happen from time to time. I've seen that where you connect it to the part and you have a very negative leak, and we'll talk a little bit more about this in a bit, but you get a very negative leak as a result of the pressure actually increasing in the part, depending on how much pressure we're using to seal to pressurize that CTS connect.
Yeah, and the good thing about that is setting your negative leak value so that you actually reject beyond a certain point. That way you identify those issues.
Absolutely, yeah, that's critical to keeping yourselves out of trouble when you have those type of connectors that you're using to pressurize with air pressure, because it can leak into the part, making a bad part appear as though it's good. So we're going to talk about air pressure settings. So if you are unable to achieve minimum pressure, so in the instrument, there are minimum and maximum settings, and the minimum test pressure is the pressure that you must achieve during the pre-fill in order for the instrument to continue to run the test. It's a safety to prevent us from going through the entire cycle of the leak test only to find out that it didn't reach test pressure because it had such a gross leak. We used to call it a gross leak test, but now during pre-fill, if we don't reach that minimum test pressure, it'll kick out. Well, this is a setting inside the instrument. So as an example, if you have a 50 PSI test pressure, you're going to set that, I would typically set on a 50 PSI test, have it at 52 and 48, depending on the application. There's not a scientific method that I'm aware of in setting the upper and lower limits. Anything to add to that, or any method to a madness on that one, Gordon?
You could say 10%.
10%.
Yeah, that would be a starting point. And then if you've got certain tolerances that you need to meet within your testing, which we do see 50 PSI plus or minus 2 PSI in your case, 48 and 52, that would be the right way to set for that.
what happens, what can happen, so we get, what can happen is customers, I see this often, is they'll set that window too tight.
Mm-hmm.
And so what happens is let's say it's 50 PSI and their air pressure settings for whatever reason are actually about 49.5. And they go to run a test and they have pressure loss during the test, but before it actually stabilizes, in that stabilized time, it drops below the 49 PSI. So if they've set the window 49 to 51, it drops below 49, it's going to immediately reject as a severe leak because the pressure went below the minimum test pressure. Again, it's a way to prevent running through that entire cycle, right?
Yep.
So I had a customer one time, this is when I was still up in Michigan. He was in Grand Rapids, Michigan. And he called me up. Your instrument, it was a 4-station M24, and it was a machine builder, and he said, your machine is not working. We got to get this equipment run off. Get your butt over here. So I made arrangements to get over there early the next morning, and I talked to him about adjusting the test pressure because I felt like that was probably the issue, was his regulator was not set properly, and so I drove over, left very early that morning, and it was a blizzard, and but we were like the Mayo, or I was like the Mayo. I was gonna go through. So I pull into the customer's parking lot in Grand Rapids, Michigan, after driving through these treacherous conditions, and there was no one in the parking lot. They had canceled their work that day because of the snowstorm that was coming through. So I called the guy. I'm like, dude, I'm sitting in your parking lot. There's nobody here. And he thankfully didn't live far from the plant. So he drove over and I went in and literally, he started up the machine, got everything going. Literally, I took the regulator and went, boop, maybe a quarter of a turn, and it all ran perfect. So the test pressure oftentimes just needs a little bit of adjustment to get it right. So I'm sure you've got similar stories to that.
Oh, absolutely. But nothing like the mailman.
That's right. Yeah. Well, in that situation, I was young, and hopefully I would think that I would still make that journey today, but safety wasn't exactly on my mind. I told the guy I was going to be there, and by golly, I showed up. So inconsistent readings, inconsistent test pressure readings that results in inconsistent leak rates, because obviously we're pressurizing a part. When we do pressure decay leak testing, specifically, we are measuring the pressure loss over time. So we pressurize the part, that pressure, any pressure change, pressure fluctuation is going to cause our leak rates, our results to be inconsistent. So air pressure. So we talked a little bit about this last week as well. So clamps relax. So during a test, if you have a dual station machine, specifically, we're talking about this, or an operation that uses a lot of air next to your leak test machine. So we've got the part clamped and we're holding it down and we're in the middle of a test. If the air pressure is drawn off of the cylinders that are holding the part down, we will not see them, but they will burp. They'll lose pressure a little bit as there's a station next to it drawing down the pressure that is used to clamp the parts. Well, those are really difficult to troubleshoot, and issues that it's tough to find, because you don't necessarily know to be looking out for a drawdown of air pressure in the other stations. So one of the things that Gordon mentioned last week to help alleviate this challenge or this problem is to put an air tank on the back of your leak test system or underneath, that you are utilizing as the air source for your leak test application. Anything to add to that, Gordon?
Oh, you got it covered. That was good.
All right, very good. So instrument air pressure regulator settings, we mentioned that. You're unable to achieve minimum pressure. Small pressure loss during test can put you under the minimum pressure. I mentioned that earlier. You want to verify that the instrument is set to the target pressure. This is a common challenge that we have. So if you're in our instrumentation, you tell it what test pressure you are going to be operating at. And so if you tell it 60, but you're running, but you set it up to 50, obviously that's going to be a problem. So sometimes if you're using an electronic regulator, they can lose calibration, and that has been an issue that I've experienced a time or three. Anything else with electronic regulators, Gordon, that customers should keep an eye on?
Oh, the electronic regulators actually work pretty well because you do set the instrument test specific for the pressure. So it will adjust that regulator when you change test parameters. Between different parameters, different test pressures, it will readjust itself so you don't have that problem. One of the things that you may need to do when you first set up an electronic regulator is actually train it, let it run through a couple tests, 5 to 10, and we have automatic set points in our instruments so that they readjust those electronic regulators to the right test pressure.
Yeah, excellent. Electronic regulators are a great solution for, especially when you have multiple pressure applications.
Yeah.
So, and of course, we're talking pressure decay or differential pressure decay applications.
The other good thing about our instruments now, they have what you would call pressure compensation. So if you're testing target pressure 50 psi, and you've got a pretty major leaker and you fall down close to your minimum pressure, but still conduct a test, and you're testing, call it 58.5, the instrument will know what its final test pressure is and readjust your leak rate calculation based on that test pressure, even if it were at 50 psi. So there's some of those set points in the instrument or capabilities of our instruments now versus our older ones.
Yeah, for sure. That was used to be a definite challenge in the I-21. And what customers would, where it shows up is if you have a calibrated leak standard, and that leak standard is calibrated at 50 psi, you plug it into the instrument, but you're actually testing at 48 psi. Of course, it's going to be off. But nowadays, what Gordon is explaining to us is that even though the test operated at 48 psi, the instrument is smart enough to adjust what that flow rate out of that leak standard would have been at 50 psi. So it is much more likely to match if everything is calibrated properly. Still talking about air pressure, because next to seals, the air pressure is the most common problem. So we want to verify that we have the correct target pressure setting in the instrument. We need to verify that we've got the correct system pressure for your air cylinders that are sealing on the part. We need to isolate the system pressure from the instrument air supply. So that is a common thing that I direct customers to do, is to again isolate that system pressure so that the drawdown on those pressurization does not cause a problem with our leak test. Multi-station machines, we want to isolate circuits when possible from each station, so that we minimize the impact of one station on the other. So those are some common best practices for air pressure settings. Tooling and clamping, we already mentioned that we have incorrect alignment can cause our seals to be off center. I see this a lot, and Gordon, you can chime in on this as well, but I see it a lot when we've got single point cylinders coming in to seal on, say, a 1/2-inch hole. And for whatever reason, that alignment gets knocked off, and you go in at an angle, but you're trying to seal when you're not really aligned.
Yeah, that causes seal burps, like we were talking about earlier.
Yeah, seal burps, where even though it's sealed, the air pressure reaches a certain amount and it opens up a little bit and then reseals itself, right?
Yeah.
So okay, so repeat this failure mode can be intermittent. So Incorrect alignment, like you talked about, can cause that burping that makes the issue intermittent. Very difficult to troubleshoot those
Oh,
type of situations.
yeah.
Uh,
Actually, that's when you start looking at waveform analysis, because that'll help pinpoint. You can watch your pressure curve the whole time to see that change.
yes, for sure. And we've got a number of technologies nowadays that we can plug up. So pressure fluctuates and causes the tooling to relax. I mentioned that. Obviously, that's going to cause a false reject, cause some problems there. Leaking cylinders, connectors that can cause some inconsistent clamping. I mentioned that depending on if we have these hoses that are cut, that's going to cause some intermittent problems. Let's talk about instrument settings right quick. So timers get mysteriously altered. So your operators make some adjustments, and you didn't know about it. Nowadays, of course, instruments can be locked out at any number of levels, but we've seen that. I've seen that lots and lots of times because, as a general rule, people want it to run faster, and we get that. But the problem is when you change the timers, you've voided your calibration, right?
Yep.
So when people change timers, you're unable to meet your minimum pressure. Your calibration, like I mentioned there, is no longer valid. So your pressure settings on your instrumentation. So the minimum pressure is set too high, so too close to your target pressure. We've talked about that a little bit. Your min-max pressure is too close to the target. And your orifice values are incorrect or do not match your actual orifice or leak standard that's inside the instrument. Now, again, some adjustments that have been made over the course of time here. This was a real problem with the I-21, but nowadays when we tell the instrument what value the leak standard is, it will automatically adjust that calibration accordingly. Is that correct?
Yeah, that is right. Absolutely.
All right, faulty calibration. So speaking specifically about pressure decay leak testing, we take a known good part, we put it on the stand, the leak test fixturing, we press auto calibration, and we hit the buttons. Part seals up, the instrumentation runs one test. That establishes our baseline, our no leak. So we've said this is a good part. So essentially, it sets that pressure loss to zero in the instrumentation. Then it relaxes, lets everything come back to ideally a normal temperature and state, and then we run a second test. In that test, we introduce the leak standard. The leak standard is mounted normally internal on the manifold of the instrument. And so that leak standard opens up, and it is going to establish our upper test limit. So the pressure loss associated with the part and the leak standard, those go together to establish our upper control limit. So when we calibrate and let's say our leak standard is not impactful and we're too close, so we don't have a good ratio between the two, that causes all kinds of problems. So calibration is, other than seal issues, probably the number 2 issue that I experience with or have experienced in my career. What about you, Gordon?
Oh yeah. The best thing about calibration is you can validate it with parts that have leak standards in them. 10% above and 10% below your reject rate will allow you to validate that process. So there are some checks and balances here that you can employ.
Absolutely. That's a great point. That is a great way to do some testing and check. To make sure you have a good calibration is use a leak standard that's 10% over your reject limit and 10% under your reject limit. One should give you a red light, and the other should give you a green light.
Yeah.
So calibration part leaks, that's a problem. It's not representative of your actual part. We want to make sure that we're calibrating to actual parts. So the tolerance for the parts have shifted since the initial build. So I talked about getting parts machined, and over the course of time, some of those molds might open up, be adjusted, and that could cause the shift of where the parts are sealing. So you need to recalibrate. for those issues. So the leak standard becomes clogged, and there's no difference between the no leak part and the no leak part plus the leak standard. That is, obviously a problem. The temperature of the calibrated part is not consistent with the temperature of the parts that you are testing on a day-to-day basis. That can be issues or cause issues with calibration as well.
Yeah, porosity is another one.
Yeah, so this last part, bad parts, good instruments. Yes, believe it or not, sometimes it's not the leak test equipment. The parts are actually leaking. So really what we're working to do all the time, at least what I'm working to do, and I know you as well, Gordon, is we're working to build confidence with our customers in the equipment itself. And when you have that confidence, then the operator is no longer pointing to the instrumentation. They have the confidence to say, this is a bad part. I know it's a bad part. That's always what we're working toward. Anything to add, Gordon?
Oh, everything leaks.
That's right.
And leaks are not repeatable.
No doubt about that. So, Gordon, again, thank you so much for joining. Let's talk about the upcoming IndustryCast. That please, if you share this with anyone that you might think would benefit from these. But so on September 9th, Chuck Haggard, my first roommate when I got into leak testing, he and I are going to talk about electric vehicle and powertrain leak testing. And then on September 16th, we're going to talk with Mark Iantoni about the benefits of ultrasonic servo welders. So we are welcome. We welcome any ideas on topics that would like to be beneficial for our customers to cover. We are here for our customers. We want to thank you for everything. I mean, I can't thank you enough. Every customer, we are so grateful for the opportunity to serve you. Mike Dorsey down in South Carolina, Chris Mullins over in Eastern North Carolina, Virginia, and then yours truly focused on Western North Carolina, and then the select upstate South Carolina accounts. So anything to add, Gordon?
Oh, I just want to thank you for having me join your presentation and discussions today, Russ. Thank you.
Absolutely. Thank you, Gordon. 3 weeks in a row, you've taken time to join us. So we're grateful, appreciate each and every one of you, and hope everyone has a wonderful and safe Labor Day weekend. Cheers.